Hello and welcome to Combustion. In this video I'm going to show you how to unpack, install and operate a Combustion FID50 fast HC analyzer. What you'll see today may have changed slightly as the product evolves, but if you have any questions, just contact Combustion. So if you have just taken possession of a Combustion FID50 fast HC analyzer, this is typically what you'll receive. So there is a carrying case within which it is shipped, and in the top of the case there are a number of components, spare parts, cleaning tools and some software. This is for the user interface but also the drivers for the communications hardware, and we may also have supplied you with a laptop which has already been pre-installed with the software. But one of the main components in here is the heated sample line, so we'll take that out, the comms hardware and the filter. In the lower section of the case there is the analyzer itself, and it's carefully contained within this shipping foam to try to avoid any shipping damage. But it's important to unpack once you've received it and look for any signs of damage to either the analyzer or to the outer casing. So now that the FID50 has been unpacked, I'll show you some of the connections we'll make on the rear panel of the system. So there are various things we need to consider. One of the first things we'll connect is our fuel supply. So we supplied this orange keyed connector, and we have our flammable gas supply from here. The other two gas fittings are for our zero gas, which is pure nitrogen, and our hydrocarbon calibration gas. We can also attach our communications cable and our main electrical supply. We'll attach a BNC cable either to our 500 Hz or 10 Hz data outlet. Our exhaust, which contains diluted exhaust gas when the engine is running, will come out from here. So you may want to put a hose over here and extract that elsewhere. There's the option for drawing in clean, dry, ambient air from elsewhere if the environment in which this analyzer is sitting may be contaminated with high levels of hydrocarbons, although the air that's coming in here is going through a charcoal scrubber anyway. That provides the zero air to our combustion chamber of the FID. The connections on the front panel are basically confined to the connections for the heated sample line. There's also this optional sample filter though, and I'll show you how to take this apart and change the filter paper in here in a separate section. But if we screw in the sample filter first, then the heated sample line screws into the filter like that. There are two pipes which need to be attached at these fittings and very gently tightened up just slightly. And finally, there is the electrical connector which provides the power for the heated line. In its simplest form, we can communicate with the FID50 via an RS485 to USB converter like this. And this is contained within the kit of parts sent with the instrument. We're attaching this to the part of the laptop which is labelled comms, and this has been configured to speak with the correct COM port which is allocated by the computer via the user interface. So we'll switch on the power to the analyzer. set of LEDs lights up. The green ones denote where pressurised gas has been applied, and we also have the comms. This will start to flash when we establish communications with the laptop. And if we go to the user interface icon there and start software, we'll now take a look at the software and how to start the analyzer in more detail. If you're supplying your own laptop for running the FID50, then after installing the user interface and the drivers for the USB to RS485 comms kit and the .usf file, which is the set points file for your particular analyzer, it's important to set up the COM port. So this is done by finding out which COM port your laptop has ascribed to the comms hardware which we have supplied and you've plugged into one of the USB ports. So by looking under devices and printers in your computer settings, you should be able to find the USB to RS485 entity, and if we look in the properties under the hardware, we can see that on this computer it's been given COM port 3. Now we have to go back into the user interface software and make sure that it is speaking to the correct COM port. So under settings, under advanced, there are several tabs along this window. If we go to communications, there's our COM port, that's already set to 3. While we're in this window though, under set point files, you can also see the electronic serial number. So this particular instrument is serial number 250, and if you need to, you can load in your set points file using the load button and pull in the .usf file which has your particular set points on it. At that point, our instrument should be communicating, and that's indicated by some of the parameters are moving slightly when you open the settings window. Here is the user interface in its most basic form. You can see the parts per million output shown in the large numeral there. Here is our on-off button, and if I press that now, you'll see it goes orange, and perhaps in the background you can hear the pump has started in the analyzer. If I open this settings window, you can see all of the parameters which are being controlled inside the analyzer, and we can see the glow plug current, for example. We can see our flame is lit and that temperature is rising. We can see the sample probe temperature has reached our 190 degrees and is coming into control. So there are lots of things in here which are stabilizing. We have to leave this for about 5-10 minutes until everything is established and stable. There is also a sample button here, and in here we can change what calibration gas, what zero gas, or the sample flow through the heated sample line. There are also warnings which will pop up if anything appears to be wrong, and there is a help button for more information. So the system has been running now for about 30 minutes and it's warmed up, and you can see the calibrate button is now available. It's now not greyed out anymore. If I press the options button, this will allow us to enter the calibration gas that we're using. So at the moment it's set to 2300. We can change that to 1900 parts per million, and we can also change the span units that are used. So we know that we are 1900 parts per million propane, so we'll change that. In this window as well, you can change the measurement units which are displayed, so we've also set that to ppm C3. So if I now calibrate the instrument, if I press that calibration gas button, it now starts to flow zero gas, and it will look at any offsets on the system and it will dial out those offsets. It will then flow our calibration gas and will set the system output to match the calibration gas value. So it should settle at 1900 parts per million, and it will fix that as our cal gas value. And now that it's finished the calibration routine, the calibrate button has gone green and we're basically ready to sample.
the span gas button reverts back to samples, so you're all ready to take some data.
I'll now show you how to change the filter paper. So we undo the clamp and the filter will separate to reveal a gauze inside. So on the male section of the filter, the gauze goes in first. Then out of the box of filter papers, the filter papers have a rough side and a woven side, and it's the rough side that goes upwards. Then the two parts of the filter are pushed together and held in place again by the clamp. After about a month of sampling exhaust gas with the heated sample line, it may be useful to clean this out. Now, the inside diameter of the capillary that runs down the 3 metre length of this heated line is approximately 1.75 millimetres diameter. This is a 1.5 millimetre cleaning layer, and a simple method of cleaning this is just to insert it and push it all the way through. This is 4 metres long, and so this will travel all the way down the heated line, poke out the other end, and you can be sure that you've cleaned the entire length of the heated line. Another thing to clean, especially if you're not using the sample filter, is the FID tube, which is inside the detector, which is inside the box here. So once a day, if you're not using the filter, it's important to clean out this capillary. This is a dedicated cleaning tool which is 9/1000 of an inch diameter, and this just passes through the capillary up to its shoulder, and that ensures that that capillary is perfectly clean. If you're using the instrument with the sample filter fitted at all times, then it's less important to clean this regularly, and perhaps cleaning this only once a month will be adequate.